Hi everyone. So here we go, Chapter 9, Parenteral medications. Parenteral medications are those that can be injected or are injected via needle into the body by various routes. They're absorbed faster and more completely than drugs given by other routes. And they have to be administered using the sterile technique. Alright, our learning objectives, we're going to be calculating doses for parenteral medications in liquid form. You're going to have to interpret the directions on the drug label, and you're going to reconstitute the medication that's originally in powdered form. We'll talk about that. Labeling is important. Choose the most appropriate diluent. The diluent is another word for solvent. It's what you dissolve the drug with. And then we'll calculate doses of parenteral medication measured in units. We're going to use this objective for heparin or a blood thinner. There's a lot of information in your book about heparin. I highly recommend that you read it, and I'll mention that again when we get to that slide. Okay, so first we're going to talk about ampules. So these are one of the containers that you'll come across when you're in your field. It's a glass container that holds a single dose of medication, and how you open it is you just snap the neck off. I believe they have openers, or you can just actually use your thumb and snap the neck. And then you use a filter needle to withdraw the contents, and you never use that same needle to administer the drug. So you use that needle just to take the drug out of the ampule, and then you don't you administer the drug with a different needle or through a different process. Okay. The next kind of container you're going to be working with are vials, and these can be glass or plastic, and then they have a rubber membrane on the top. So this is for medication or medicine in liquid or powdered form, and multi-dose or single dose vials are an option, or things that you'll be working with. SDV, single dose vial, is a vial that only, exactly what it sounds like, holds one dose. And these are actually safer to work with because it allows less room for error. If you have a multi-dose vial, there's just a little bit more room for error because you have to withdraw the exact amount for the dose and calculate that yourself or measure it yourself. And then if it's a single dose vial, you just basically will remove all of the contents from the vial, and that's the dose. Okay, so for our calculations, we'll be calculating the volume of the solution that contains the prescribed amount of medication. So realize what we're doing here, we're talking about solutions again, which we've talked about in the past. So we had our formula, strength equals solute divided by solution. So we're still working with that, and the solution is created by taking the pure drug and dissolving it in the diluent or the solvent. Okay, and then so for a lot of the calculations, you're just going to be working with this second bullet point here, order times the strength. And then you do want to check your results and make sure they're reasonable compared to this originally stated strength. So you can look at the strength, and we'll do it on the next example, and you can kind of have a good estimate of how much your end result should be as far as the dose you're going to administer. Okay, so here we go. The prescriber ordered 3 milligrams of dolophine subcute stat. The strength is 10 milligrams per milliliter. How many milliliters would you administer to the patient? So here's what, let me mention what I'm saying about the checking. So notice what's happening here. The strength is currently 10 milligrams per 1 milliliter. If we want to administer 3 milligrams, do you think that's going to be more or less than 1 milliliter? So let's reason through it real quick. 10 milligrams is 1 milliliter. We want to give less than 10 milligrams, so we are expecting a number less than 1 milliliter. So we'll verify at the end that we're going to get less than 1 milliliter after we do our calculations. Okay, so the label reads 10 milligrams per milliliter. This is the strength, okay, and we're going to use that. That's our unit fraction. We take our order. So if you notice right here, here's our order, 3 milligrams. Okay, and we multiply it by the strength, and notice that the strength here, we have the milliliters on the top because we want the milligrams on the bottom so that we can divide them out. All right, so when we do this, the milligrams cancel out, and we're left with 0.3 milliliters, or 3/10 of a milliliter. And this is a reasonable amount. We are expecting something less than a milliliter, and this seems like we did everything right, which we did. We did our calculations correctly here. All right, next example. The prescriber ordered 0.002, so recognize what number this is. This is 2/1000ths of a gram, intramuscularly stat. The strength is 1 milligram per milliliter. And calculate the number of milliliters of the solution you would administer. So because we have an order given in grams and the strength is given in milligrams, we're going to first convert the order of 2 milligrams and then go from there. So our 2/1000ths of a gram, convert that to milligrams, use your decimal movement shortcut, okay, and we get that 2/1000ths of a gram is equal to 2 milligrams. All right, and now we have our strength is 1 milligram per 1 milliliter, and you honestly don't really have to do any work for this. I mean, other than in your head, you can show this work on a test, but I would just accept doing this one in your head because it's 1 for 1 milligram for 1 milliliter, so you know 2 milligrams is 2 milliliters. Okay, so determine the quantity of solution to be withdrawn from the vial if the medication order reads 250 milligrams of 10% calcium chloride. All right, so here's our equation from the past. Strength equals solute divided by solution. And we have our 10% here. You know that that's the strength. Hopefully you recall that the percent is always going to be the strength. So 10% is 10 out of 100. So we have our 10 grams over 100 milliliters here. Okay. And it's going to equal the solute over the solution. So our solute was given. It was 250 milligrams. And so that means we don't know our solution. So and it even says it here, determine the quantity of the solution. So if you're ever not sure what you're trying to find, you just fill in this equation and then you look for whatever's missing. That's what you've been trying to find. Because we're trying to find the solution, our answer is going to be in milliliters. First, we're going to convert our milligrams to grams though, because our strength is given in grams per milliliter. So recall that the strength is given in grams per milliliter or milliliter per milliliter. All right, so we have our 250 milligrams. You convert that to grams, and you get 0.25 grams, or 25 hundredths of a gram. Okay. And then we take our order, right? So we have our order here, 0.25 grams. We multiply it by our strength. And notice for our strength, we just use the reciprocal because we want the grams to divide out. We want to be left with milliliters. So we put our grams on the bottom and our milliliters in the numerator on the top. Okay, and the grams divide out. We simplify our fractions and we end up with 2.5 milliliters. So you would withdraw 2.5 milliliters from the vial. Okay, so if you've noticed so far, the titles of each of these slides, it's been about parenteral medications in liquid form. Okay, soon we're getting to powdered form, but for now, here's another example. And the prescriber ordered heparin 5,000 units, subcute every 12 hours. So heparin is a blood thinner and it's a high alert drug, and there's a lot of information in your textbook about this. There's actually quite a few pages dedicated to it. I highly, highly recommend that you read through them because you really want to make sure that you administer the correct dosage for this. I mean, as with anything, but definitely you want to read about this. All right, the label on the vial reads 10,000 units per milliliter. How many milliliters will you administer to the patient? So notice real quick that it just says units. It doesn't say like milligrams, grams, things like that. Heparin is actually measured in what's called units, USP units, United States Pharmacopoeia units. Okay, so that's something new. Here's an example of a vial for heparin. Here's the label. We just mentioned this. So 10,000 USP units, and this is per 1 milliliter. We want to convert 5,000 units to milliliters. So how does 5,000 units become milliliters? We're going to use our unit fraction, which is the strength. So the label reads 10,000 units per milliliter. So there's our unit fraction. and we take our order and we multiply it by the strength. So our order was 5,000 units, and we multiplied it by the strength. We flipped it over, we took the reciprocal because we want the units to divide out and we want to be left with milliliters. So the units divide out, 5,000 divided by 10,000 is just 1/2. So we have 1/2 milliliter, or 0.5 milliliters contains 5,000 units of heparin. So now we're going to move to medications in powdered form, and this process is going to be a little bit more involved because you have to do something that's called reconstitute. So you have to reconstitute the medication that's in powdered form, and you're going to create a solution by adding a liquid, by adding the diluent or the solvent. Okay, so some parenteral medications are supplied in powdered form, and it's in a sealed vial. You can't take the powder out, you actually have to add the diluent into the vial. Okay, and then the powder will dissolve and you will have a solution that you've created. And so again, this is called reconstitution. Once you do this, then you withdraw the liquid or the solution you just created and you administer the proper amount to the patient. If there are no directions on the vial itself for this reconstitution, you have to consult the pharmacist, or you find the information from the manufacturer. You can check their website, you can check the physician's desk reference, but you need to make sure that you reconstitute the drug correctly. So that's what we'll be trying next. The most common diluents that you're going to work with are sterile water for injection, or SW, and 9/10% sodium chloride, NS, or normal saline. Now, when you add the liquid to the powder, there's what's called a displacement factor, and this doesn't always change the volume, but sometimes it does. So when you add the liquid, there could be an increase in the volume in the vial that occurs when you dissolve the drug into that diluent, into that liquid. And so this increase in volume is called a displacement factor. Here's an example of a label for a drug that you might administer. So what I want you to pay attention to here is right down here, it's for this part. Okay, this is the reconstitution directions. So notice it says milliliters of diluent to be added. So basically whatever strength you're trying to achieve, and this is going to be based on the order that's prescribed for the dose, whatever strength you're trying to achieve, you're going to add this different amount of diluent. So if you're trying to achieve a 250,000 units per milliliter strength, then you're going to add 75 milliliters of the diluent. And likewise, if you want to get 500,000 units per milliliter, you add 33 milliliters, and so on. The prescriber ordered 150 milligrams of a drug intramuscularly stat. The directions on the 500 milligram vial read: add 9.7 milliliters NS, which we now know is normal saline, and the strength will be 100 milligrams per milliliter. How many milliliters of the reconstituted solution will you administer? Okay, so the directions are on the vial itself here. It's telling you how much to add to achieve a particular strength. In this case, we want 100 milligrams per milliliter, and that will be achieved through adding 9.7 milliliters of our normal saline. So your equation or your process doesn't really change. You just have to do the reconstitution and then multiply. So you have your order like we've been having, and you're still going to take your order and you're going to multiply it by your strength, but now your strength is the reconstituted strength, so after you add the diluent. Okay, there's a typo on this page. It says 1 year under our order here. I'm just crossing off the year. We didn't need that. So we had 150 milligrams, and that was our order, and we want to multiply it by our strength. But notice what our strength is now. It's 1 milliliter is 100 milligrams, or like it said on the previous slide, 100 milligrams per milliliter. That's the reconstituted strength. So this is going to be your order times your strength once you've reconstituted it. Okay. So when you multiply this out, so again, this was your order, and then you multiplied it by the new reconstituted strength. And so what you end up with is 15/10, or 1.5. So you would administer 1.5 milliliters of this solution after you perform the reconstitution. So this is visual representation just to show you a little bit about the reconstitution process. So for this example, we have on this top left corner the information for when you reconstitute this drug. So this would be given. It would either be on the vial or you would get it from the pharmacist, physician's desk reference. So this information you would find somewhere. Okay. Now notice what you have here. You have, in this case, there's 4 different vial dosage sizes, but you have a strength. You actually have 2 strengths for this example that will be the result after you reconstitute this drug. So either 250 milligrams per milliliter or 350 milligrams per milliliter, depending on how much of the diluent that you add, the diluent or the solvent. So for our example, we're working with a 500 milligram vial, okay, and the prescriber ordered 250 milligrams. Alright, so how you start, and well, first you look at the table here, and we're working with the 500 milligram vial, and we want to achieve an order, well, the order is 250 milligrams, so we want to achieve a strength of 250 milligrams if possible, and it is possible if we look down here and we add 1.8 milliliters to this vial. Okay, so what you do is you take your syringe and you put 1.8 milliliters of air into it, and then you inject that amount of air into your diluent. In this case, it's sterile water. Okay, so you're going to inject 1.8 milliliters of air into the sterile water, and then you're going to withdraw that same amount of sterile water, that's your diluent. Okay, once you withdraw that 1.8 milliliters of sterile water, then you take that and you inject it into your drug, into the solvent. Okay, so you inject 1.8 milliliters of sterile water into the drug, and then if you notice here, back at the strengths over here on the left, it was 250 milligrams, and that's per milliliter. So if the order was 250 milligrams, lastly we withdraw exactly 1 milliliter because that would be 250 milligrams. Alright, so our chapter summary. Medications supplied in powdered form have to be reconstituted. So that's when you add the diluent or the solvent to the vial. And then again, there's going to be manufacturer information about how much to add. You have to determine the best dosage strength. And there are several options. So for example, in the previous problem we just worked with, that visual one, there was a 350 milligram strength and a 250 milligram strength. Definitely for our order, the 250 milligram strength was the best one. Now after you reconstitute a multiple dose vial, so a vial that you could use again because there's more of the drug in it, you have to make sure you label it properly. So you want to label it with the dates and the times when you prepared the solution, and also when that solution expires, how to store it properly, your initials so people know who reconstituted it, and the new strength. This is crucial because if you don't label it correctly, and someone might not know that it's already been reconstituted, they might reconstitute it again, and it will not be the proper, they will not end up giving the patient the proper dose. When the directions on the label are provided for both intramuscular and intravenous reconstitution, make sure that you're reading the right one. So you have to realize, how are you going to administer this drug? Through the muscle, through the vein, and then reconstitute accordingly. Heparin, we talked about, the blood thinner, is measured in USP units. Again, please read your textbook on heparin. There's a lot of information. And here's a little bit more about it. So it's important that the heparin orders are carefully checked and that the strength is checked before you administer it. You want to use a 1 milliliter or a 0.5 milliliter syringe to administer heparin. And then heparin sodium and heparin flush solutions are different, and you must make sure which one you're working with because the strengths are gonna change, and it's gonna affect the dose that you administer to your patient. All right, that's it for chapter 9.